The idea of subgame perfection, and in particular the concept of commitment, is one of the most important things you're going to learn in this course. Let's drill down and look at some applications to industrial organization of these concepts. The first example we're going to look at is a model of advertising. We're going to look at a model that's a bit of a twist on the Cournot model. Prior to engaging in Cournot competition, one of the two firms has to decide on a level of advertisement. That advertisement level is going to determine the inverse demand function that the two firms face. We've got two firms. You have an advertising level A that's chosen by the first firm. And firm 1 chooses this at the start. Each of the two firms picks a quantity, just like in Cournot competition, and they do this simultaneously, after they observe the level A chosen by firm 1. Advertising isn't free for firm 1. There's going to be a cost to advertising, and that cost is 2 times A cubed divided by 81. So the game tree looks something like this. At the initial node, player 1 chooses a quantity A between 0 and infinity. After player 1 chooses A, player 1 moves again at this information set. Player 1 chooses a quantity Q1, again between 0 and infinity, some non-negative number Q1. However, firm 2 makes its choice without having observed the choice of Q1. That's indicated by this dashed line here. This dashed line indicates that all these decision nodes are in the same information set for player 2. At this information set, player 2 picks Q2, again between 0 and infinity, so some non-negative number Q2. Once both of the firms have chosen Q1 and Q2 respectively, and given the quantity of advertising A that firm 1 has chosen, the price is given by A minus Q1 minus Q2. So that's the price of the good that they're selling. So firm 1's revenue is the price times its quantity. We're going to assume 0 marginal cost. So the cost of producing the goods is 0. However, there's a cost to advertising. So it's 2A cubed divided by 81. So that's the payoff to firm 1. Firm 2 doesn't pay anything for advertising, so its revenue is its profit, or its payoff, and that revenue is the price, which is A minus Q1 minus Q2 times Q2. So these are the payoffs at this terminal node, where firm 1 has chosen A, then it's chosen Q1, and firm 2 has chosen Q2. In order to analyze this game, we're going to first solve this Cournot problem for a given A. And we'll do that for all possible A, calculate the continuation value for player 1 as a function of A, and then find what the optimal A should be from player 1's perspective. So we'll start by solving the Cournot game that the two firms play after A is chosen. In this Cournot competition stage of the game, so in the last subgame, the payoff, as we see here, for the first firm is A minus Q1 minus Q2 times Q1 minus 2A cubed divided by 81. So in the last subgame, player 1 seeks to choose Q1 to maximize this objective. So player 1 seeks to choose Q1 to maximize A minus Q1 minus Q2, the whole thing, times Q1 minus 2A cubed divided by 81. One thing that you'll note here is that this advertising cost is at this point a sunk cost. And it doesn't affect the choice of quantity for firm 1. And that'll come out when we take the first order condition. So the first order condition is A minus 2Q1 minus Q2 equals 0. So the best response of firm 1, given a choice Q2 by firm 2, is A minus Q2 divided by 2. And we'll see here that this cost of advertising, 2A cubed over 81, doesn't play a role at all. As I said, that's because this advertising cost is a sunk cost when we get to this last subgame. In this last subgame, firm 2 solves the following problem. It chooses Q2 to maximize its payoff. So its profit is simply the price, A minus Q1 minus Q2, times its quantity Q2. If we solve this optimization problem, we'll see that the best response of firm 2 to the choice Q1 by firm 1 is simply A minus Q1 divided by 2. The equilibrium is a pair of quantities, Q1 and Q2, such that the two firms are best responding to one another. So it's a pair, Q1 star and Q2 star, such that Q1 star equals A minus Q2 star over 2, and Q2 star is such that it's equal to A minus Q1 star divided by 2. And that's because Q1 star is a best response to Q2, and Q2 star is a best response to Q1 star. Solving this, Q1 star equals Q2 star equals A divided by 3. So we found then the Nash equilibrium as a function of A. Remember, there's a subgame for each choice A, and for each of those subgames, the Nash equilibrium is for both firms to produce A over 3. Now, how many information sets are there for player 1? There's the initial node, so the firm 1 has to pick an advertising level A, and for each advertising level A, there's an information set where firm 1 has to engage in kernel competition. And for firm 2, for each level of advertising A, there's an information set where player 2 has to engage in kernel competition. So for player 1 and 2, the quantities have to be a function of A. So Q1 of A and Q2 of A, the equilibrium strategies, are A over 3. So the equilibrium price, when the advertising level is A minus Q1 of A minus Q2 of A, which is A minus A over 3 minus A over 3, which is just A over 3. So we can now calculate the continuation value for firm 1 from the advertising level A. And we'll represent that by Z1 of A. It's the price, which is A over 3, times the quantity that the firm will produce, which is, again, A over 3, minus the cost of advertising level A, which is 2A cubed divided by 81. This is the price. This is the quantity. And that's A squared over 9 minus 2A cubed over 81. In the very initial node, firm 1 solves the following maximization problem. It picks the advertising level A that maximizes its continuation value. In other words, it picks A to maximize A squared over 9 minus 2A cubed divided by 81. The first order condition is 2A divided by 9 minus 6A squared divided by 81 equals 0. So we have that 2A over 9 equals 6A squared over 81. We can divide both sides by A and get rid of the A on the left side, and we get rid of the square on the right side. We can multiply both sides by 9. We can divide both sides by 2. And then we can cancel the 3 here. So A over 3 equals 1, which means that A has to equal 3 at the optimum. So the Nash equilibrium is that A star equals 3, and the equilibrium quantity selections are such that when the advertising level is A, firm 1 picks A over 3, and when the advertising level is A, firm 2 picks A over 3. So that's the Nash equilibrium.